Hello everyone and welcome to IEEE SIESGST's podcast, where we bring experts insights on emerging technologies and career-focused domain for engineering students. I am Payal Bhag and today's podcast focuses on the field that is backbone of modern communication systems, that is radio frequency, microwave and mobile communication. We are delighted to have with us Dr. Geetimai Shau, who has several years of experience in telecom industry, especially in customer services, billing systems, and team management in fast-paced environment. She has worked she has worked closely with wireless communication systems and keeps herself updated with changing technologies and trends in telecom industry. Hello, ma'am, and welcome to the podcast. It's a pleasure to have you with
Hi.
us.
Yeah. Nice to see, hear the introduction. Yeah, you can start.
Thank you, ma'am. Uh, to start this discussion, it will be great to understand your journey in telecom industry and how you got interested in wireless communication.
Yeah, actually, I have done MTech from IIT Kharagpur in RF and microwave engineering. Actually, RF is the basic of wireless communication because through radio frequency only communications happen. Matlab, radio frequency we are using to establish the wireless channel through which wireless communications begins.
That's an inspiring journey, ma'am. Now, moving forward, how do you explain the importance of radio frequency and microwave communication in today's technology driven world?
Yeah, actually, RF radio frequency, the range of radio frequency is vast. It is from 30 kilohertz to 300 gigahertz. So that entire range of radio frequency from 30 kilohertz to 300 gigahertz, we can divide into three parts. One is low frequency, mid frequency range, and higher frequency or millimeter wave range. The lower frequency, see you. Our communication, wireless communication generally starts from 700 megahertz range. First of all, we are having 2G, after that 3G, 4G, LTE advanced, then 5G, 5G advanced, and we are now moving towards 6G communication. So, from 2G, our spectrum is the communication spectrum, lower frequency is there and mid band is there, like GSM 800, 900, GSM 1800 is there. So when the frequency is low, the coverage area will be much higher because lambda is equal to CYF. As the frequency is lower, lambda will be higher, hence the coverage area will be more. But then why we are using higher frequency? As we are using higher frequency, the channel width will be more. So when the channel width is more, the throughput or data speed will be more.
One question. If RF did not exist, what everyday technologies will stop working immediately?
No, if RF did not exist, then we will be solely depends on the wired media of communication. So what happens when a transmitter and receiver they want to communicate? First of all, you need to ensure that there should be proper connectivity between transmitter and receiver. That is the way to check the reachability between transmitter and receiver. So uh, um, if wireless would not exist, then the communication can happen through wired medium. But nowadays, as the communication mainly data communication happens, so people, each user generate much amount of data, and we, in order to transmit the data from one point to another point, um, it is very, seamlessly happening through optical fiber or by using a millimeter wave at the back end, at the core side, is a transport media. If wireless media is not there, then people will depends on wired network, which will become mess because you have to put from radio access network to core network proper connectivity through wired media, which will require a huge amount of connectivity to transport the data from radio side to the core side.
Surely, without RF, it would be a mess.
Yes.
Um, which engineering branches benefit the most from understanding radio frequency fundamentals?
Radio frequency fundamental, like starting from electronics and communication, basically telecommunication, even bit of electrical engineering, even computer science. They can also able to understand RF, wireless and telecommunication, because see, anything, any electronic equipment now you will visualize either phone or laptop, the daily gadgets which we are using. In each gadget you will find a chipset. Without a chipset, the infrastructure, the device will not exist. But chipset is not enough to do the communication. On the chipset we will put some operating system. So what are the different operating systems we are using? Either Windows we are using, or we are using in Unix or Linux medium. Even Apple system, they are using their own operating system, that is iOS. Okay, on that, nowadays to make the communication very easier, various applications also developed, like Android platform we are using, which helps, by using Android platform, application development will become easier. So nowadays if anything you require, like to you require food, there are various applications are available. You could just click on that application, you can order food, and food will be delivered to your doorstep. So things becomes quicker and easier for our day to day life.
That explanation clearly highlights why radio frequency and microwave technologies are so fundamental to modern communication. Now that we understand their impact, how does RF help in our day to day communication? This is something students experience every day.
Yes, actually, RF is not only for communication purpose; it also helps a lot in our home appliances, like home automation systems. Also, even RF we are using medical applications like MRI. All these things we are using in medical applications. Even RFID tags are also we are putting in various products also, to make to identify all the data of the product, all the information about the product can be stored in a RFID, in a tag, and that tag you can put it on the box. When you will scan that RFID, all the informations, what are the products inside the box, can be known very easily. Even RF, as I told, it is we can use it for a longer distance communication, we can use it for a very shorter distance, that is near communication. So near communication means your Bluetooth, even nowadays, like Bluetooth enabled keys, even whatever the barcode, tag reader, all these are examples of near communications.
Ma'am, what do you think? How important is RF planning in cities with dense population?
Yes, see, RA planning is required because if the population is denser, and nowadays everybody is using cell phone, and everybody mostly use the cell phone for data applications, so the RB allocation or radio bearer allocation to each user should be very proper. So if you will plan RF planning, it means, see, in the RF there will be small frequency, matlab low range frequency, medium range frequency and higher range frequency. Low range frequency for to provide the large range, coverage area will be more, whereas high range frequency, suppose we have done RA planning with low range frequency 700 megahertz, then huge in that 700 megahertz the coverage area will be in kilometers, but that is not enough for data communication. So on that we can also put another cell of higher frequency, where the channel width will be more. Suppose channel width is 100 Mbps, then each user can get throughput of more than 100 Mbps, which will be easier for them to get the data properly, to make the communication properly.
Yeah. It's fascinating how deeply radio frequency is embedded into our lives, often without us being aware of it. With such widespread usage, communication technologies are continuously evolving, which brings us to current trends. So, what are the current trends in the telecommunication industry that students should be aware of?
Yes, is in your student age, you might have seen the journey from LTE to 5G, from 4G to 5G, everybody know. So what we get, and in 5G we are having massive machine type communication like IoT or industrial IoT. Even the other edge of 5G is URLLC, that is ultra reliable and low latency communication. It is a future use case which might we will use in 5G advanced, that is URLLC we can use for robotic surgery, even for autonomous driving vehicle and vehicle to vehicle communication. The third edge is EMBB, enhanced mobile broadband applications, which we are also using while downloading the data and uploading the data. The current trend of communication nowadays is AI and ML, because you will find AI ML used in starting from healthcare sector, even for telecommunication sector, even for various gaming sector. In all the sectors now, AI optimization techniques is used to make the search process faster and to get the appropriate data in very less time. So AI trend is fascinating nowadays to the younger
So
generation.
AI can be integrated in radio frequency as well?
Yes, see, suppose I am a user and my interest area is on wireless communication. If in every day I am searching some parameters, some keywords related to wireless or RF or telecom, then the next day if I will switch on my mobile phone, if I'll browse, I will get many information related to this areas, not other areas. So that some algorithm is running backend of this phone, so it keep track which area I am interested, and on that particular area only it will give me pop up, yeah, these are the new updates on this area. So my interest area, the phone keep track, and I am getting the information related to my areas.
How do these trends impact job roles for engineers?
Yes, and see, when previous to some year, actually things are analog, and we used to keep the data in pen and paper. So that time, then the next era is of digital era, that is to keep all the data software, I mean to convert the data from pen and paper to soft data. So that time that was the requirement, but now everything is already stored in digital. But if you are having so much of data, then how to get the appropriate data? So that requires analysis, optimization, and intelligence to get the appropriate data in a very quickly or very less amount of time. So AI is needed for to get the job also near future.
Um, According to you, which of these trends should students start preparing from today?
See, nowadays people are practical oriented. So if you are finding any problem around you, so try to analyze, try to pinpoint what is the root cause of the problem, and try to solve the problem. So problem solving capability should develop in each and every student.
These trends clearly show how dynamic and future oriented the telecom industry is. One of the most discussed changes in recent year is the shift from LTE to 5G.
Yes.
Yes, as you discussed. So, according to you, what is the basic difference between LTE and 5G?
The basic difference is, see, in LTE we are using frequency range 2.2, 2.5 range, but in 5G we are using low segment, that is band N28, that is 700 megahertz, which mainly to provide the coverage area. Then we are using band 78, which is 3.5 gigahertz, where the channel width is 100 megahertz. When the channel width is 100 megahertz, the user can get throughput of 1 Gbps or more than 1 Gbps in idle situation. The next segment is, that is these two are band 28, band 78, they are coming under FR1. The next segment is FR2, that is the millimeter wave spectrum. The range of the millimeter wave spectrum is from like 24.2 gigahertz to 52.6 gigahertz. That is the higher range of frequency. So when the frequency is higher, the channel width becomes 4 times higher. As I told, channel width in N78 is 100 megahertz, whereas in FR2 channel width is 400 megahertz. So when channel width is more, so obviously the data rate will be higher. So people are using more data. If you are using FR2 frequency, the people can get the data speed will become higher. But there are some challenges in millimeter wave as well. So as I told, lower the frequency, the coverage area is more, but as the frequency is getting very high, the coverage area will become less. But to address this challenge, also various technologies are coming, like RIS, reconfigurable intelligent service. Actually basically millimeter wave communication we are using for a shorter distance or point to point communication, but uh, for longer distance or from non line of sight communication, what we are using, suppose one transmitter is here and you want to receive, I mean transmit the signal to a place which is far from the receiver and is non line of sight, then in between some place a RIS, that is reconfigurable intelligent surface, can be used, which is a microcontroller. On the RIS surface the signal will, I mean incident, and the RIS is a booster which will retransmit the signal without changing the phase of the signal. So using millimeter wave also the transmission can happen to non line of sight. Okay, so these are the some things will come in near future and in 5G advanced. You asked me difference between LTE and
Again.
5G. See, in LTE, the channel width band 40, the channel width is nearly 20 megahertz. So when channel width is 20 megahertz, throughput we are getting, max throughput we are getting 100 mbps, whereas in 5G max throughput we are getting 1 gbps. So throughput is higher, and the use cases like in LTE, IoT concept is there, but it is not that much of used, whereas in 5G as the technology, I mean time progresses, the use cases are getting more and more, and use cases are also getting matured, like home automation, and then smart city, and then smart agriculture, then smart hospital. So various things are connected to IoT. So suppose I used home automation ki smart home concept at home, and my some of the appliances are connected to the cloud. Then when I start from the office, I can put my AC on. So when I will reach to the home, the room will be
Cool.
quite cool.
Yeah.
So as we are moving, the use cases of what we are defining today are getting matured.
Yeah, we talked about LTE, 5G, 4G. So, why did 5G take so long to deploy commercially?
See, technology evolution happens after every decade. Like 1980, I mean, 19. We thought of GSM, but GSM came into picture in 1990. Then 2000, we thought of 3G. 3G came into picture in 2010. Then LTE came into, like LTE came nearly 2015. I mean, LTE research started from 2010, but LTE or 4G technology came 2015. Then 2020 we got our 5G. See, when a technology evolves, to get it matured, or the use cases what we are writing during the development of technology, those use case in order to make it feasible, we require lots of time. People should accept the things, because though research wise researchers will do the research fast, but to get the technology deployed and to be people to avail the service of the technology, it takes time.
Ma'am, what do you think? Does 5G require completely new infrastructure?
5G require, see, in 5G there are two modes way. One is standalone architecture, another one is non standalone architecture, NSA. SA requires completely new infra, but though a technology 5G is a new technology, but it should also compatible with 4G technology, because if you are in an area of 5G, your device will latch to the 5G technology. But if you will move to a place where 5G is not there, 5G coverage is not there, then the device should seamlessly hand over to the 4G, and your call, data and the functionality of the device should work fine. Similarly, like in India, Jio is having SA technology, which is standalone, and it is also compatible with the legacy network, that is 4G, whereas Airtel is having NSA. In NSA, what is the difference between SA and NSA? SA means your device is 5G, a radio network is 5G, and your core network is also 5G. Whereas in NSA, device 5G, radio network is 5G, core network is 4G. So here, what you what is the difference you are finding from infrastructure wise? Using the 4G core also, people can avail the service of 5G. Are you getting? Yeah. So here, what makes to get avail the service of 5G? You are just adding 5G radio network and integrating it to the 4G core as well as with the 4G radio network. Here the intelligence lies in the 5G radio access network side. So in Airtel, if you are putting a Airtel SIM card in your device will show as 5G, but their voice call will go through LTE, VoLTE, that is a voice over LTE, whereas data will go through 5G. So I mean, completely new infra is not required. If you are going for standalone, the new infra is required, but for non standalone, that is NSA, using the 4G core also we can avail the 5G services.
That explanation really simplifies the technical differences for students. As communication expands beyond cities and ground infrastructure, new challenges arises in remote areas, above sea surfaces, and harsh environments. How can we communicate at such non-terrestrial levels?
Yeah, actually NTN, that is non-terrestrial network, is a new use case in 5G, or it was also there in 4G or in 5G advanced. See, in our earth's surface, if you will imagine our earth's surface, three part of the earth's surface is covered with water, that is oceans, sea, and are there, and only one part is there where terrestrial network is there. In the terrestrial network also, everywhere you will not find plain surface, you will find somewhere mountains, somewhere forest. It is very difficult to reach over there. You know, there is a new technology, even NTN or satellite based communication. Satellite phones are also coming, where the base station, one, it will be integrated with one satellite. So what happens, your base station, your transmitter will be on the surface of the earth. From the transmitter, the communication will happen to the satellite, and again receiver will be there on the earth surface. Receiver will receive, and the signal will given to the core network, processing will happen, and the communication will be done. So nowadays also you can find like cricket match, some cricket match, it is um, happening in England, but all over the world you can watch it. So this is satellite based communication. Even like various ships are going from one country to another country, so communication happens over the on the ship, over the surface of the ocean, through satellite based phones. Even like defense areas, they like if you will consider Leh Ladakh, their temperature was quite low, and in those places it is very difficult to put a base station or to do the communication, but the communication happens through satellite by defense peoples. So terrestrial communication is there, that is our cellular communication, and non-terrestrial network is there. But nowadays, what is the limitation? These non-terrestrial network phones, there is no handover is defined between NTN to terrestrial network. So these phones we can't, I mean, it will not latch with the cellular network. When neighbor, I mean, some neighbor will be defined like cellular communication and terrestrial network and non-terrestrial network, there will be handshake, then the smooth handover can happen from non-terrestrial network to terrestrial network.
In this non-terrestrial network, can 5G support non this communication?
Yes, 5G supports this type of communication.
What are the biggest engineering challenges in such environment?
The biggest engineering challenge is, see, suppose I'm at Nerul right now, I'm at your college, maybe base station will be nearby in Nerul itself, or else it is in Juinagar. So every device is last to the base station. Okay, so when communication happens, the device communicate with the base station, then base station to the radio, base station is having the radio network, base station will communicate to the core, and the other party, other this is the MO, that is mobile originated, then mobile terminated. The other party will be somewhere um, in other cell which will be attached to the core network. The communication becomes faster. But if you are going for satellite based communication, if I am transmitting some signal from here, from this device, then it should transmit to the satellite, to the base station, which is either in the satellite. So the communication happens through the satellite, whereas satellites are placed 1,000 km above the surface of the earth. Okay, so now you are doing terrestrial communication, means base station is 5 kilometers, within 5 kilometers max to max distance. Whereas when you are doing satellite communication, the base station placed at 1,000 km above the surface of the earth. So it takes longer amount of time. I mean, the latency will be in minutes, whereas now latency will be in millisecond. मतलब it latency will be in millisecond. We experience live communication. We didn't get any delay. Suppose I am talking voice call, I am making a voice call, I find it live communicating with the other party. There is not at all no delay for this critical communications.
This clearly shows how communication technology connects even in the most inaccessible region. Uh, let's now move towards the advanced modern networks. What are the use cases of 5G advanced and why do we need it?
Yeah, in 5G advanced, the most use cases like we will have high performance computing. High performance computing means, see, the nowadays IoT, in the IoT you will have a sensor, the all the sensors are integrated to a server, then the communication happens from one server to another server. Okay, so suppose now if any instruction will be given to the device, then the instruction will be given through the server to the device, or through the server to the edge sensor. But as the technology advances, the edge sensor is having some intelligence which can take the decision immediately to do the action. So here performance of the system will become enhanced. Then experience of communication, experience will also become better. Nowadays we used to have video communication. In 5G advanced we may have holographic communication where the user experience will be more. And then like use cases what already defined, like robotic surgery can also happens, even vehicle to vehicle communication, vehicle to everything communications also happens. So many more use cases are coming in our day to day life, and for that 5G advanced with higher modulation techniques is will come to handle all these things.
So, ma'am, according to you, does it require the systems require new devices?
New devices, see, if frequency will change and the device antenna is not able to handle those frequency, then definitely will require new device. Because you can find 5G devices, it can work with 4G. Okay, there is a, in the settings you will find a preferred network mode. There, if 5G network is not there, you can select to 4G, then a device will launch 4G network. and it will function seamlessly, no difficulties. But 4G device, you will not find it will last to the 5G frequency, because the antenna of the device is not able to get the signal from the higher frequency. It is not designed for that reason. We have to change. If the antenna can't able to uh, receive the signal from the higher frequency where the current technology is based, then we have to change the device as well.
How does it support ultra reliable low latency communication?
See, ultra reliable low latency is nothing but the experience will be live communication. Live communication, suppose one doctor is sitting at UK, one patient is at Mumbai, then the and robot is going to do the surgery. Then the doctor will give some instruction to the robot, and robot will perform. There should not be any latency. So whatever doctor is giving instruction, a robot will follow that, and it should act immediately to do the surgery successful. So this is an experience. This is an use case of URLLC, like gaming applications. So when gaming we are doing, then you suppose a human is interacting with a machine, then human has done some trick, then machine should also counter attack to that trick without any delay. The next is like vehicle to vehicle communication. Suppose one vehicle, many vehicles are running on the road, one vehicle finds some mishap, then it should communicate to the vehicle which stands back to it immediately. So in that way, many road accidents also can be avoided, those things.
This shows that innovation in communication is a continuous process, which naturally leads students to ask what comes next. Moving forward, ma'am, do you think 6G will come to India?
Yeah, 6G will come to India, but as I told, technology develops after a decade.
Yeah.
So we get 5G in our hand. 5G deployment happened at 2022. Then 5G phone we are starting to use in India, especially in 2023. So expect 6G will be in 2030. Then based on the deployment and use case, we may use 6G in 2030 onwards, because now 5G advanced up to 2025, 5G advanced use cases are fully defined. In 2025 last quarter, the war groups for 6G they are made, and 26 onwards the physical layer of 6G, it will be what kind of modulation, what mainly advancement will happen in 6G compared to 5G or 5G advanced, that will be decided. No, in next 2-3 years 5G advance is going to mature and people can use it.
Ma'am, as per your opinion, will 6G affordable initially?
Yes, it will be affordable, because when a technology evolves, mainly the technology is meant for the common people. So the technology has to be affordable so that common people can use it.
It's exciting to think about how rapidly communication technologies are progressing. To enable these advancements, some key technologies play a crucial role, like massive MIMO, beamforming, and millimeter waveform.
Yes.
Can you just elaborate it?
Yeah. See, MIMO is required. Suppose your device is having single antenna and your RF network or radio access network is having single antenna. Then there will be a single road. Okay, imagine a road. There is only one road is there. So when there is a one way or the road is narrow, then only one vehicle will pass in the road. When the road becomes 4 lane, then at a time 4 vehicles can pass through the road. So the handling capacity of the road will enhance 4 times. That is the massive MIMO. So if one antenna will be there, then the device can able to transmit or receive the data through that particular antenna. But when 4 antennas will be there, then 4 channels at a time can be established between the device and the radio access network, and the device can able to get the data 4 times faster, 4 times faster in 4 channels simultaneously. And then beam forming is means suppose there is a narrow beam is formed and that particular beam follows a device, then what happens, it is the guaranteed service for the user by the service provider, because antennas are placed at the base station. If one beam of the antenna will follow to the user, it means the user will get guaranteed service. There will be no interrupt or no packets will be missed for that user. So the user experience will enrich in that case. And next is you
Beam
ask
forming, beam
Massimaimo beam forming and the
and
last.
millimeter wave.
See, millimeter wave, as I told, is the frequency is higher. As I told, in the millimeter wave, 24.2 to 52.6 gigahertz, that range is for millimeter wave, and it's basically for TDD. Okay, and in millimeter wave, what happens? The communication is line of sight or for a less short distance communication, but there the channel width will be 4 times higher compared to N78 band. So in N78 the channel width is 100 megahertz, whereas in millimeter wave the channel width will be 400 megahertz, because 4 component carriers are used. And to overcome the challenges in millimeter wave, that is for non-line of sight communication, nowadays, as I have already mentioned, RIS, reconfigurable intelligent surfaces are coming. So for non-line of sight, you can take the help of RIS, which will receive the signal, again retransmit the signal without changing any phase. So in this way, this techniques we can use to make the communication feasible and faster.
How does FR2 differ from traditional frequency bands?
As I told you, FR2 millimeter wave concept, it is not there in LTE. It is newly introduced in 5G, but FR2 is defined and some use cases are defined, but it is also it is not widely used till date because of some challenges or difficulties. But to overcome those challenges, some researchers are also going on, like um, nowadays one technique came, like you are using a Wi-Fi module. In the Wi-Fi module generally uses two different kinds of frequency, one is 2.4 giga or 5.5 giga. Use a Wi-Fi module, then receive the signal, then that channel can be multiplied to 5 times. Okay, means you get the signal through the Wi-Fi module, but communication will not happen in the 5 gigahertz. Rather, same data you can have you are using a multiplier, same data will be transmitted in a millimeter wave channel. So when same data is transmitted through a millimeter wave channel, as you know, the millimeter wave channel is having higher width, higher channel width, so communication will become faster. Now OTA, that is over the air, you are transmitting through millimeter wave, you receive the signal, again it will be frequency divided by 5. Here you are multiplying by 5, again you are dividing by 5, you are getting the range of 5.5 giga, then this signal again is received from another Wi-Fi module. So to make it usable, the millimeter wave frequency, there are various researches are also going on.
That was extremely insightful and technically enriching for our listeners. Before we conclude, let's clarify one last comparison students often ask about. What is difference between Wi-Fi, cellular and quantum communication?
Yeah, in Wi-Fi, basically Wi-Fi we are using at free bands like 2.4 giga or 5.5 giga. Wi-Fi is we are using it on license band. Okay, that railway Wi-Fi or home Wi-Fi we are giving to the some rent to the service provider, but the channel used, that is ISM band, which are free bands, that is defined by the defense or government of India से वो defined है कि these bands are free bands which mainly used for Wi-Fi communication. Whereas cellular bands, those are the licensed band. If you are doing communication through the cellular band, then you have to pay money. User have to pay money to the service provider. Okay. Last is quantum communication. Actually, in cellular communication, one point I'll add, in LTE and 5G, how the data transmission becomes faster in 5G. In LTE, we are using 64 QAM. Okay. Whereas in 5G, we are using 256 QAM. See, suppose you want to bring the water from the from um, from a river. Okay, just put a pipe, the water will not come. If you will put a motor over there, the water will come faster. That motor is nothing but a modulation technique. So the powerful motor, how powerful the motor, it depends on how speed the water will come. In 4G, the modulation technique is 64 QAM. So 6 bits can be transmitted at a time. Whereas in 5G, it will become 256 QAM. So 8 bits can be transmitted simultaneously. So hence in 5G, the communication become faster compared to the LTE. The next is quantum communication. See, in LTE and 5G, the security is not that stronger. Anybody, I mean, there are some cyber criminals, cyber security threats you are hearing on a daily basis. So, to enhance the security, uh, quantum communication comes into picture. Now, various researchers are also going on in quantum communication, where communication will happen through qubit to enhance the security level of data transmission. Whereas in case of cellular, we are using authentication method and encryption method for security, for to make the communication secure. Whereas in quantum communication, we are using qubits to enhance the security. In cellular communication, the encryption method, anybody can decrypt it, or it can be break, it can be copied also. Whereas in quantum communication, the process of communication using qubits, it cannot be copied, it cannot be break. So the secure communication, security can be guaranteed in quantum communication.
So, ma'am, according to you, will quantum communication replace current systems?
Actually, uh, nowadays research is going on at the government of India level also. uh, First of all, they will try to bring more security to the financial transactions, like in banking sectors they will try to implement. Even in defense sectors, they will try to implement quantum communication to have better security. Then it will come to the day to day life for normal usage.
So, why can't Wi-Fi support large-scale mobility?
See, Wi-Fi, as I have told you, na, in Wi-Fi, the process of communication is different compared to the cellular communication. Wi-Fi uses unlicensed band, cellular communication uses the licensed band. So, in Wi-Fi, um, what suppose you are having a Wi-Fi module at home, then if number of people are less, everybody will have get good throughput. But if number of people are more using the same Wi-Fi, the service quality will degrade. Whereas cellular communication will give you guaranteed quality of service to every user. So Wi-Fi will be there mainly for data communication, and cellular mainly for indoor communication also we can use Wi-Fi. Whereas cellular communication, we will get guaranteed quality of service for voice, as well as at the edge of the cell also the user can able to place a call. I mean, call drop will be very less at cellular communication.
That comparison really helps students understand these technologies clearly. With this, I would like to thank you, ma'am, for sharing your valuable insights on radio frequency, microwave, and mobile communication. This discussion truly highlighted how these technologies continue to shape both present and future connectivity. This brings us to the end of the today's podcast. Thank you everyone for listening and stay tuned for more expert conversations.
Thank you.